Okay, elimination is just another way of solving these systems of equations. Our goal with this is to get either the x's or the y's to be opposites. And once they are, we're going to add the two together. Well, in this example, the 8y and the negative 8y are already opposites. So we'll just add them together. Negative 6x plus negative 7x is negative 13x. The 8y's cancel. And negative 16 plus 16, also opposites, they cancel. It becomes 0 because we have to have something over there. Now we just solve this equation. So x equals 0. And there's your first answer. Just like before, pick one of the equations to plug that into to solve for y. I'm going to use the first one, so negative 6 instead of x. We'll put 0. So 0 plus 8y equals negative 16. 8y equals negative 16. Then we divide by 8. So y equals negative 2. Now we can check that answer by plugging both of these into the equation we didn't just use. So negative 7 instead of x, we'll put 0. Minus 8 instead of y, we'll put negative 2. And it should equal 16. So negative 7 times 0 is 0. Negative 8 times negative 2 is 16. So that does check. Okay, again we want to start by getting either the x's or the y's to be opposite. Looking at it right now, the y's are exactly the same, but they're not opposites. So I'm going to change the signs in either one of them. You can pick one. Doesn't matter. I'm going to go with the top one since we have the negative 22, we can make that positive. So that means I'm going to multiply this whole thing basically by negative 1. That'll give me positive 3x minus 7y equals positive 22. Then I'm going to bring this other one over here just so they're lined up. So negative 7x plus 7y equals 14. Okay, now we're ready to add the two together. So 3x minus 7x should be negative 4x. 7y's cancel. And get equals 36 when you add 22 and 14. And then we divide both sides by negative 4. So x equals negative 9. Now we have x. Plug it into either one of our original equations to find y. I'm going to use the top one again. So negative 3 will change x to negative 9 plus 7y equals negative 22. Negative 3 times negative 9 would be positive 27 plus 7y equals negative 22. Subtract 27. So 7y equals negative 49. Divide by 7. Y equals negative 7. That would be your second answer. Now I'm going to plug these into the other equation so that we can check it. Negative 7x instead of x, we'll put negative 9. Plus 7 instead of y, put negative 7. Should equal 14. Negative 7 times negative 9 is positive 63. 7 times negative 7 is minus 49. And when you subtract 63 minus 49, you get 14. So that one also checks. Okay. Again, we want to get opposites with either the x's or the y's. If you look at the x's, you have a 3 and a 7. If you look at the y's, you have a 4 and an 8. They're not the same, but it would be easy to multiply 4 to get to 8. Matter of fact, we could multiply it by 2, and then it would equal 8. But remember, we will also want it to be the opposite sign. So we're going to multiply by -2. But we got to multiply everything, not just the 4y. So that'll give us -6x minus 8y equals -6. And then I'm going to bring the other one underneath it so that they're lined up. 7x plus 8y equals 7. Now we're ready to add these together. -6x plus 7x is x. -6 plus 7 is 1. Because the y's cancel. So x equals 1 is your first answer. And pick one to plug it into to solve for y. I'm going to go with the first one again. So 3 times 1 plus 4y equals 3. 3 times 1 is 3. Then we subtract 3. 4y equals 0. Divide by 4. Y equals 0. And there's your other answer. Now we can plug both x and y into the other equation to check. So 7 times 1 plus 8, instead of y we put 0, should equal 7. 7 times 1 is 7, 8 times 0 is 0, so that does in fact equal 7. Okay, with this next example, we can't multiply 3 by something to get 5 to eliminate the x's, and we can't multiply 5 by a whole number to get 9. So what we're going to do instead is we'll have to multiply both of these equations. When it gets to that point, you just decide if you want to eliminate x's or y's. Either way will work. I'm going to go with the x's because I have smaller numbers there, so I think it will be easier. So since the x's, we have a 3 and we have a 5. 3 and 5 both go into 15. So I'm going to multiply both of these by something to get 15. 5 times 3 would get me 15, and 3 times 5 would get me 15. We also need the signs to be opposite, so make one of them negative. Doesn't matter which one, pick one. I'm going to go with the bottom. Okay, so now let's actually multiply. On the top, when we multiply, you get 15x minus 15y equals -15. Then on the bottom, negative 15x plus 45y equals 75. Okay, now we're ready to add them together. So the x's now cancel. Negative 15y plus 45y would be 30y. And negative 15 plus 75 would be 60. Then we divide by 30. So y equals 2. Now pick one of those to plug it in to solve for x. I'm going to go with the top one again. So 5x minus 5 instead of y, we put 2 equals -5. 5 times 2 is 10. We add 10 to each side. So 5x equals 5. Divide by 5. X equals 1. Now I'm going to plug x and y into the other equation to check it. So 3 times 1 minus 9 times 2 equals -15. 3 times 1 is 3. 9 times 2 is 18. And then 3 minus 18, question marks because we're checking, would be -15. So that one checks also. Okay, I wouldn't do substitution. I would do elimination still. But let's take this one right here. Let's get rid of your fractions and let's get it in standard form like the first one is. Okay, so you got y equals -5/2 x plus 19 over 2. Again, look at your denominators. They all have a denominator of 2. So we can get rid of it by multiplying everything by 2. So these 2's cancel. Those 2's cancel. You get 2y equals negative 5x plus 19. Now, let's move the 5x to the other side. So that it's in standard form like the first equation. Okay, now the only problem is we have a 5x here and a 5x here, but they're not opposites. So we need to change the sign in one of them. Okay, so just pick one to change the signs on. So we've got, I'm going to change the signs on this bottom one, the one that we've already been working with. So 5x minus 5y equals 40. I'm going to go ahead and bring that down so that they're on top of each other. And then negative 5x minus 2y equals negative 19. So your x's cancel. Negative 7y equals 21. And divide by negative 7, y equals negative 3. Okay, now we need to pick one of the original ones to solve for x. I would go back to the one that didn't have fractions. Plug y in, so 5x minus 5 instead of y, we'll put negative 3 equals 40. So 5x plus 15 equals 40. Subtract 15. 5x equals 25. Divide by 5. X equals 5. Okay, and I'm going to put the 5, or the x and the y into the other equation to check real quick. So you get negative 3 equals negative 5 halves times 5 plus 19 over 2. So negative 3 equals 5 times 5 is 25. Negative 25 over 2 plus 19 over 2. We already have common denominators, so we can just add denominators, which gives you negative 6 over 2, which does in fact reduce to negative 3. Alright, there's actually 3 types of systems of equations. We've already been discussing independent systems, and those are 2 independent lines that intersect at one point. You get one solution, everything works out nicely. The dependent system of equations are actually the same line. It may not look like it initially, but they are. And that would be an infinite number of solutions because every point on that line could be a possible solution. And then the inconsistent system of equations, that is where you have parallel lines. You can tell that when the slopes are the same. And that would be no solution because parallel lines never touch. And then we'll look at these last 2 examples more closely here. Okay, if we were to solve this using elimination, I could multiply this top equation by 2, which would give me 10x plus 18y equals negative 24. And then the bottom, I'll just bring over here. Notice when I go to add it though, everything is opposite. We get 0 equals 0. If I were to change these signs, you would see they're actually the same equation. So that is a dependent system. Okay, a dependent system, and it's an infinite number of solutions. Remember, every point on that line would be a solution. It's not all real numbers though. because there's a lot of points still not on the line. But we can't list all of them, so we just say it's an infinite number. Okay, if we were to try to solve this with elimination, we could multiply these 5s by -2 in order to get the opposite. That would give you negative 10x minus 10y equals negative 30. And then I'm going to bring the top equation over. Okay, but notice now when we go to solve, the x's and y's both cancel, but we get negative 6 over here. That's impossible. 0 can't equal negative 6. And that's because it's an inconsistent system. And you can look at these and see that the slopes would both be -1, but the y-intercepts are different. So they are two different lines, but they're parallel lines. And there's no solution because parallel lines never touch. So once again, just to recap, the independent system of equations is two independent lines touch at one point, and you're able to get a solution. The dependent, when you try to solve it, you get 0 equals 0, or a number equals itself, because they're actually the same line. And that has an infinite number of solutions, because it's all the points on that line. And in the inconsistent system, when you try to solve it, you get 0 equals another number. And that's impossible. That's because they're parallel lines and they never touch, so they do not have a solution.